Welcome to today's webinar. The topic today is API in our section. My name is Andreas Hörold. I'm responsible for marketing and public relations in the company Dlubal Software. For instance, the webinars, technical content of the website, customer projects, and so on. I will be the moderator today, and I will answer your questions during the webinar. My colleague Sonja von Bloh will be the presenter today. She works in the product engineering team. She's the main responsible person for the add-on aluminium design and for the program RSECTION. And she works also in the customer support team. You can ask questions during the webinar when you press the button with the question mark. Then you can enter your question in that field, press send, and I will receive your question and I will answer you. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. Okay, that's for the moment all from my side. I hand over to Sonja. Sonja, it's your turn.
Thank you for the introductory words. I would also like to warmly welcome you to today's webinar. In this webinar, I would like to give you a straightforward introduction to using the RSECTION API. First, I will explain the installation and authentication. Then I will show you how to create a cross-section in RSECTION using Python via the Dlubal API, performance calculation, and finally transfer to RFEM. This will be demonstrated using a flat steel section with the dimension length dl and thickness dt. Initially, points 1 to 4 for the outer contour and 2 additional points for the element are defined. Then the boundary lines 1 to 4 connecting points 1 to 4 are created. After that, the part is generated and finally the element between points 5 and 6 is defined. The API documentation is available on our website under Products, API Documentation. It provides information on installation and authentication. In this chapter, Getting Started. Here you find all information about installation, authentication, starting the server, and so on. Additionally, the complete API reference is here for RFEM 6, RStab 9, and RSECTION. Furthermore, you find here various application examples also for RFEM, RStab, and RSECTION. The focus today is on development with Python. It's required that Python version 3.10 or higher is installed. Additionally, you need an integrated development environment such as Visual Studio Code or PyCharm. I personally use PyCharm. In PyCharm, you first need to set up the appropriate Python interpreter. Find it here in the settings. Here, the Python interpreter Python 3.13 is used. Furthermore, the Dlubal API package must be installed. Make sure that the Dlubal API version matches your installed program version to ensure compatibility. For example, our section version 1.13.0005 requires Dlubal API version 2.13.5. The crucial point is that the last 2 digits, this means 13 and 5, of the version numbers match. In PyCharm, you can install the Dlubal API via the Python packages section by searching here the name. In this case, Dlubal API. Here already you see that the Dlubal API version 2.13.5 is installed. Accessing the Dlubal API requires authentication via an API key. API keys are managed in the Dlubal extranet. For this, I open here this browser again, and then I log in with my account. And then you find here in the section API and Cloud under API to the API keys. Here you can create new API keys, edit existing ones, or delete them. API keys serve to authorize your access and enable project-based usage-dependent billing. This means that if you want to use the API for a specific project, you can generate a dedicated API key and assign it accordingly. Always handle your API key confidentially and do not share it unintentionally. Anyone in possession of your key can use the API in your name and at your expense. For demonstration purposes, I recreate a new API key named webinar. Here I create the API key and then I copy this API key for later use. You can use the API key directly in your code for authentication. Additionally, it can be stored in a configuration file, and I want to show you this today. For this, I open PyCharm again, and then I go to the folder Dlubal API, and here I open this folder in Windows Explorer. And in the folder API, I create a new text file and I name it config. And here I change the extension to ini. And then I open this text file with the editor, and then I define the section API underline keys, and under this section I assign the key to the name. So my key name is webinar, and then I pass the copy key from the clipboard. You can also define a default key. This key is automatically used if no explicit key is provided in the Python code. I will do this also, so I use here the name default, and I use here the same key from the webinar. Then I save this file and close it. And now you see this configuration file here in this folder, API. Now in the code, you can simply use the key name instead of the full API key. In RSECTION and RFEM, you must also configure the API gRPC server to start together with the application. I will show you how this works. You have to go to the menu options and then open the program options. And here the checkbox Dlubal API gRPC has to be checked. And here you can define the gRPC server initial port. Here already the initial port 9001 is defined. Then I open RFEM and do the same. So I open here the program options. The Dlubal API gRPC is checked and the initial port is set to 9000. If you use RFEM and RSECTION simultaneously, ensure that the ports are not identical. So if you want to access both, the initial port should not be the same. Therefore, I used 9000 for RFEM and 9001 for RSECTION. Let us now look at the source code. The code is essentially divided into two parts: definition of the cross-section and controlling RSECTION and RFEM via the API. First, the required modules are imported. This includes the Dlubal API modules, RSECTION for accessing RSECTION objects, RFEM for accessing RFEM objects, and common for importing the RSECTION file into RFEM. Additionally, the OS module is imported to allow saving files later. A function-defined structure is then defined. This function creates all objects that make up the cross-section and returns them as a list. The variables dt for the thickness and dl for length are defined as parameters. So the geometry needs to be changed later. Only these two values need to be adjusted. Alternatively, an input form could also be implemented. A list named objects is created to collect all generated objects. This means material, points, lines, part, and element. The material with the number 1 and the name S235 is created as a material object in the RSECTION API via this and added to the objects list. This material is taken from the RSECTION database and will later be assigned to the part. Next, the geometry is defined. A list of points for the cross-section is created containing the point number, the coordinate y, and the coordinate z. The first 4 points form the rectangle corners. 2 additional points lie in the middle and are needed later for defining the element. For each point, a point object of the RSECTION API is created and added to the object list. Next, the points are connected by lines. 4 lines form the boundary of the rectangle. Each line is defined by its number its start point, its end point, and line type. The API does not expect a text string like polyline, but an internal type. Therefore, a type mapping is defined to allow using readable names in the code. Each line is created as a line object in the RSECTION API and added to the object list. The line numbers are also stored in a separate list. Here in this list, boundary lines, as they are needed later to define the part. After the loop, the list contains line numbers 1, 2, 3, and 4. A part is then created from the lines. The previously defined material and the boundary lines, this means here 1, 2, 3, and 4, are assigned. A part object is created in the RSECTION API and added to this object list. Additionally, an element is defined between the middle point. This means between the points 5 and 6. This element is assigned the thickness dt. An element object is then created in the RSECTION API and added to this object list. The object list now contains all objects necessary for the cross-section. A connection to RSECTION is established via the API. For authentication, the key name webinar and the port 9001 are used. Since the key name has already been mapped to the API key in the configuration file, you can conveniently use the key name. Alternatively, the full API key could be used directly in the code, but this is not recommended for security reasons, especially if the code is shared. A new model named webinar is now created here. Next, the base data of the model is retrieved. The analysis type is then set to finite element method. The modified base data are then written back to the model. The function define structure is called returning the complete list. This list is passed to our section in a single step, creating the cross-section in the model. The calculation is then started. Our section calculates the cross-section using the selected finite element method. Finally, the model is saved as an RSECTION file here under this name webinar.rsection, which contains the geometry, material, and calculation results. Then a connection to the RFEM is established via the API. Here also the API key name webinar is used, but the port 9000. First, a new model is created with the name webinar. Then all objects are deleted so that with an empty file will be worked. Then the calculated cross-section is imported via this import from. The calculated cross-section is now available in RFEM for further use. I will start this now. And then I open here our section, and you see that the cross-section is created with the points, the lines, parts, and elements. The calculation is carried out, and the cross-section is saved as a webinar file. Then if we open RFEM 6, we will see that the cross-section is already imported into RFEM. This brings us to the end of the webinar. We have demonstrated how to set up the API and perform authentication. We also showed how to define a cross-section parametrically using Python and automate its calculation. Finally, we demonstrated how to transfer the calculated cross-section to RFEM via the API and continue working with it there. Thank you for your attention. I will now hand back to Andreas.
Thank you, Sonja, for your presentation. At the end, I have an additional hint for you. You can book our online courses. For example, the RFEM 6 course, it's a course for beginners. Then the Eurocode 2 course for the concrete design with RFEM 6. The Eurocode 3 course for the steel design. The Eurocode 5 course for the timber design. And the Eurocode 8 course for the earthquake design. For more information, just scan the QR codes or click at the links here. You can get such a course for free when you submit your customer project and we publish it. Yeah, you can submit your files when you scan the QR code or click at the link. There's a form where you can upload the files. Yeah, the courses are valued at 199 to 399 euro. Yeah, you have the possibility to use free online services from our company. For example, the Dlubal community. You can ask questions there, and we or our users will answer you. There's the geozone tool for the determination of wind, snow, and earthquake loads. Then there's the cross-section property page. You can download 3D models as a template for your project, for example. Yeah, you can download our trial versions of RFEM, RSTARP, RSECTION, and RWind. Yeah, just scan the QR code here. And you can explore all our free services when you click at the link here or scan the QR code. You can get more information on our website. For example, you can find the recorded webinars there. Then, for example, also the knowledge base articles. You can ask our AI assistant Mia all the time. to our software, for example, or structural analysis topics. Okay, it should be also all from my side. I thank you for your attention. Thanks to Sonja for your presentation. I hope we meet each other in a future webinar. See you then. Bye-bye.